Students, today I am going to explain a very important topic which is called Jacobian. What is Jacobian? If u and v are function of x and y, that is u is a function of x and y and v is a function of x and y, then determinant del u over del x, del u over del y, del v over del x, del v over del y is called Jacobian and written as del uv upon del xy, or sometimes Jacobian of u comma v upon x comma y. So both. So if u is a function of x and y and v is function of x and y, then this determinant is called Jacobian of u comma v with respect to x and y. It's very easy. Similarly, for three variable, suppose u v w with respect to x y z, what is the Jacobian? It is del u over del x, del u over del y, del u over del z, del v over del x, del v over del y, del v over del z, del w by del x, del w by del y, del w by del z. This is called Jacobian. It's very easy and very important in differential equation basically. So if u and v are function of x and y, then this determinant is called Jacobian. Similarly, if u, v, w are function of x, y, z, then this determinant is called Jacobian. And similarly, we can proceed for other variables. For example, if x is equal to r cos theta, y is equal to r sin theta, then what is the Jacobian of x, y with respect to r and theta? It's simple. Del x over del r, del x over del theta, del y over del r, del y over del theta. So put the values. Del x over del r means differentiate x partially with respect to r. So what is the value? Cos theta. Del x over del theta means minus r sin theta. What is del y over del r? Sin theta. And this is r cos theta. What is the determinant? Multiply r cos square theta plus r sin square theta, which is equal to r. So what is the Jacobian? R. Similarly, we can go for three variable. You can put anything and you can easily calculate. So suppose example 2, if u is equal to x plus y plus z, v is equal to x square plus y square plus z square, and w is equal to xyz. So what is the Jacobian? Then Jacobian of u v w with respect to x y z is determinant del u over del x, del u over del y, del u over del z, del v over del x, del v over del y, del v over del z, del w by del x, del w by del y, del w by del z. Simply just put the values. So del over del x means 1, del over del y means 1, del over del z means 1. Del v over del x means 2x, then 2y, then 2z, and this is yz, xz, xy. Now you can calculate this determinant easily. Just calculate this determinant value and put the answer. So a Jacobian means just put determinant value and that is your answer. So just it's so much easy. Now we are going to discuss some properties. How is find out this determinant? It's very easy now. Use the property, subtract first two common. Now subtract 1 1 1. So it is 0 x minus y minus common z x minus y, then 0 y minus z, then x common minus y minus z, 1 2z z xy. So expand, so 2 x minus y common, y minus z common. What is remaining? 0 0 1 1 1 z minus z minus x xy. Now expand, this is a 2x minus y minus z, along 1 you expand, so minus x plus z, so z minus x. This is the answer. So now we are going to discuss some properties of Jacobian. Now I am going to discuss some properties of Jacobian. Properties of Jacobian is very important part, because using this property you can sometimes you can calculate easily. First property is if Jacobian of del uv del xy into del xy upon del uv multiply is always 1. So how it is useful? Suppose you know a Jacobian of uv with respect to xy, but they ask find out Jacobian of xy with respect to u and v. So how we find? Just 1 upon this value. For example, if you go if x is equal to r cos theta, y is equal to r sin theta, then what is Jacobian of r theta with respect to xy? How we calculate? Because solution, Jacobian of xy with respect to r theta, we know what is the value? R. This implies what is Jacobian of r theta upon xy? 1 by r over. That's very easy. So because you know it's Jacobian, so just take 1 by r. Now I will tell about second property. Second property is chain rule. If u is a function of x and y, v is a function of x and y, x is a function of r theta, y is a function of r theta, then Jacobian of u comma v with respect to r theta. How we calculate? That is very easy. First calculate Jacobian of uv with respect to xy, then Jacobian of xy with respect to r theta. This is chain rule. So how we calculate? Just first calculate Jacobian of uv with respect to x and y, and then find out Jacobian of xy with respect to r theta, and then multiply. That's all. We do one question based on that. If u is equal to x square minus y square, v is equal to xy, x is equal to r cos theta, y is equal to r sin theta. Then what is Jacobian of uv with respect to r theta? This is Jacobian of uv with respect to xy into Jacobian of xy with respect to r theta. So what is the Jacobian of uv with respect to xy? Del u over del x, del u over del y, del v over del x, del v over del y into del x over del r, del x over del theta, del y over del r, del y over del theta. What is the value? Del u over del x, 2x, del u over del y, minus 2y, del v over del x, y, this is x, into del x over del r, cos theta, minus r sin theta, r cos theta. What is the value? 2x square plus 2y square. Correct? And this is r. 2 common, x square plus y square is equal to r square, so 2r cube is the answer. So this is chain rule. Now two more properties are there. I am going to explain one by one. So next property, Jacobian of implicit function. Sometimes it's very hard to calculate, separate UVW in terms of x, y, z. So it means it is a implicit function. So whenever implicit function is given, means we have f1, u1, comma u2, comma u3, comma x1, x2, x3. First function is equal to 0. f2 is there, u1, u2, u3, x1, x2, x3, and f3. Is equal to 0. Then Jacobian of u1, u2, u3 with respect to x1, x2, x3 is equal to minus 1 to the power cube del f1, f2, f3 upon del x1, x2, x3 divided by del u1, u2, u3. This one. Because when you multiply, it is this upon this. Okay. So this is the formula. Similarly, for two variable, you can just put square. So this is also very important. Using that, you can calculate sometimes easily. For example, I will go for one example. Example means suppose if u is equal to x plus y plus z, same question we draw solve. B is equal to x square plus y square plus z square. W is equal to x y z. Then find Jacobian of u v w with respect to x y z. Now we are going to calculate by implicit formula. Here it's easy, but you can take any question, nothing matter. How we solve? Just you take what is f1. F1 is u minus x minus y minus z. Take everything one side. What is f2? F2 is v minus x square minus y square minus z square. And what is w? What is f3? W minus x minus y z. So first calculate Jacobian of f1, f2, f3 with respect to x1 means x, y, z. What is the value? Del f1 by del x means minus 1. Del f1 by del y minus 1, minus 1. Now del f2 by del x means minus 2x, minus 2y, minus 2z. Then minus yz, minus xz, minus xy. So this is nothing, take minus common, then it's similar to that, 2x minus y, y minus z, z minus x. Now we calculate Jacobian of second part. Jacobian of now we are going to calculate Jacobian of f2, f3, f1, f2, f3 with respect to u, v, w, and that value is what? Differentiate f1 with respect to u, that is 1, f1 with respect to v, that is 0, f1 with respect to w, 0. Similarly, f2 with respect to u, 0, f2 with respect to v, 1, f2 with respect to w, 0, and this is 0, 0, 1. What is the value? 1. So easily we can take what is Jacobian of u, v, w with respect to x, y, z? Just minus 1 to the power cube. Jacobian of f1, f2, f3 with respect to x, y, z divided by Jacobian of f1, f2, f3 with respect to u, v, w. Just put the values. Minus 1, minus 1. This value is minus 2, x minus y, y minus z, z minus x, and this value 1. So final value is 2, x minus y, y minus z, z minus x. You know very well what is f1. F1 is nothing, u minus x minus y minus z. F2 is v minus x square minus y square minus z square. And what is f3? F3 is w minus x minus y minus z. So this. So now that's complete. It's so much easy. Just put take everything one side and find out Jacobian. First f1, f2, f3 with respect to x, y, z, and then f1, f2, f3 with respect to u, v, w, and put in formula. Easily you can calculate. Now I am going to tell about the last property. Last property is very important, because if Jacobian of u, v, w and x, y, z with respect to x, y, z becomes 0, it means there exists a relation between u, v and w. What is mean of there exists a relation? It means easily we can eliminate x, y, z from the equation and we can find out relation between u, v, w. So suppose 3 equations given and someone asks can we eliminate x, y, z and we can find out a relation between u, v, w only. Yes, it is possible only when Jacobian is equal to 0. So if Jacobian is 0, it means there exists a relationship between u, v, w, or we can say u, v, w are linearly dependent. So it's very important property. Easily you can do. If Jacobian becomes 0 for any equation, it means they are functionally related. It means there exists a relationship between them. So I hope you all understand all properties. That's so much easy. This topic is also very easy. So because you have to calculate just determinant property and some basic properties, if you know easily you can calculate. I hope you understand this one. Again, if you have any doubt, please feel free, put in comment box. I will try to remove that one. Okay, bye.